Hello students, welcome back to Chapter 8, it's discussion of hypothesis testing. We're going to look at p-values. P-value is a probability value. This is a value that is used extensively in any type of research and kind of analysis with that research. So it's an alternate way, basically, to determine whether to reject a null hypothesis or not to reject it. The decision rule looks like this. To reject a null hypothesis if the p-value is less than alpha. So the alpha value is given to you as part of the question. The p-value is something we need to calculate. So this basically is the purpose of the p-value. These statements here. The benefit and the use of the p-value. A very small p-value indicates the strength of the decision and that there is little probability that the null hypothesis is true. So a really small p-value is good because it basically tells us that there is really small probability that the null hypothesis is true. So the p-value is defined in this last statement here as the probability of observing the difference between the sample data and the assumed population values. Remember, in sampling, we collect the data, we calculate different parts, different things from that data, and then we can compare it to the assumed or to the claimed population value. So if the p-value is really small, it's basically indicating that the probability of observing the difference that we saw between the sample data and the population value is really small. So a couple ways to find p-value, or finding p-value is based on whether it's a z value or a t-value. So we're going to look at the first one where we calculate a test statistic, and then we go through this process to find the correct p-value. So let's go over here. So let's assume, as the question states, that we have calculated a test statistic. Test statistic equals 2.19. Remember, that comes from the formula that we've taken up previously. So the first thing we want to do, and this is going to be very similar to Chapter 5 process, is this becomes a two-step process. First we calculate z, then we find an area for that z value using the normal distribution table, and we get an area of 4857. The final answer is basically our p-value. And in this case we always subtract. 0.5 minus that area that we found based on that z value of 2.19. So our p-value, relatively easy to calculate, turns out to be 0.0143, basically stating that there is a 1.43% chance of observing a difference that we see between the sample data and the population data. This is a relatively small value. The decision rule remember is to reject the null hypotheses if the p-value is less than alpha. So p-value is 0.0143, and that is less than alpha. We're assuming that alpha is going to be 5% in this example. So we're going to reject the null hypotheses. So this is an alternate way of making the same decision. So if you do the classic way that we've went through in the previous videos, or this p-value way, you will always get the same decision. The p-value, this value here, is something that we may want to calculate in addition to the hypothesis testing process that we've done. So Let's just look at this question again. If is a two-tailed test, basically the p-value we calculate must be doubled. So we don't have the information whether this is a one-tailed test or a two-tailed test, but if it is a two-tailed test, the p-value is going to be 0.0143 doubled. So we get 0.0286. We would compare that to our alpha value, 0.5%. This case, if it is a two-tailed test, big question, if a two-tailed test, reject the null hypotheses if the p-value is less than alpha. This case, p-value is 0.0286 and alpha is 5%, 0.05. So once again, we are going to reject the null hypotheses, which would be the same decision you'd make in the classic approach for a two-tailed test. So that's how we find a p-value if it starts with a z-test statistic. So a p-value, when we have a t-test statistic, slightly different. What we're going to do is we start off with, we calculate that test statistic like we would with that formula. And then with a t-distribution table, the only thing we can do on paper is we can provide a range for the p-value. So this is one of the slight differences with a p-value when we start with that t-test statistic. We can only find a range, and I'll show you why. And this is how ranges could be written. And we'll look at an example here. Let's move this up out of the way. Not that. There we go. So let's start off. The calculated value we get for t, we'll just keep the same value, 2.19. We have to know the sample size. Sample size is 13. So we know that degrees of freedom will be 12. So let's go to the t-distribution chart. This is basically where we have to, the process is a little different. We have to go to the t-distribution table. Okay, so here we are at the t-distribution table. Our calculated test statistic equals 2.19, and we know we have sample size is 13, degrees of freedom is going to be 12. So this is the starting point, the degrees of freedom, because the t-distribution table looks very different than the normal distribution table. So basically we start at row 12. We start right here. This is where we're going to find our p-value. So let's go with red. So 2.19. You'll notice that the values always increase as you go from left to right. So in the 12th degree of freedom row, we have 1.356, 1.782, so forth up to 3.055. They always increase. I want you to plot where 2.19 is going to go. 2.19 is going to go between these values here. It's going to be really close to 2.179. but basically it's just somewhere in between those two values. So then we go up to the very top, and this is basically the range. So the p-value is between 0.01 and 0.025. If it's two-tailed, the p-value is between 0.02 and 0.05. We would just double these values here. So we can look at another example. Let's work with this one. And degrees of freedom equals 21. So here's 21. Plot 3.09 on this on that 29 degree of freedom row. Values increasing from left to right. 3.09 is on this side. It's over here. It's to the right of 2.831. So basically the p-value in this case is going to be less than 0.005. It's less than because here's 0.005 for the last column, and these values decrease going this way, those top values. So if two-tailed, the p-value is less than 0.01, just basically doubling 0.005. One other example, let's look at a t-value that equals 1.098 with degrees of freedom being 28. Not sure why that switched. I wanted my green pen. There you go. So let's plot 1.098 on the 28 degree of freedom row. 28 degrees of freedom right here. 1.098 is on the left side. There's our t-value, 1.098. So this p-value is going to be greater than 0.1. These values here increase going up on the very top, talking about these values here. P-value is going to be greater than 0.1. If two-tailed, we double that, and basically saying that it's going to be greater than 0.2 or 20%. Now in Excel, we can find the exact p-value, but review questions, quiz questions on the test, if I ask you to find a p-value for starting with a test statistic from the t-distribution table, this is the process you'd have to do. I think the last slide basically just gives you an overview of how to find that range or how to find that p-value for a t-distribution test statistic. So that is it for Chapter 8.